Okay, welcome back. We're at the background worker where I fired up a thread, and then the first thing I did was to increment the progress bar. Okay, there is a problem with this because each task or each thread basically kind of sort of is reminiscent of the crew model. Now, it's not actually using crew, but it's very analogous in that this thread can see the other guys, but isn't allowed to write to them. Okay? So I need a way to increase, to run the progress bar, make it march over to do things, and still have a background worker. And so you do this through events. Remember how I tell you how two different processes can talk to each other? Now, an easy way for two different threads inside a single application to talk to each other is using events. Event is nothing like clicking on the mouse. That's an event, okay? So what I've done is I've configured this guy, this background worker. So I tell the background worker, and then I tell what it is I want you to do, and then how I want you to do that, update the progress, and then how you want this thing. So all I'm going to do is go here and comment this guy out. So I'm not directly talking to that guy anymore. So instead, I'm going to use a series of events to make this thing work. So here we go. So I start the thread, and it should march on. Oh, okay, the thread has just ended. Okay, cool. All right, cool. Now I'm going to start up the background worker. By the way, when I do the thread, do I have control? Hey, yeah. Well, right? Because it's a separate thread, right? All right. But when I do background worker, it's going to update the little progress bar for me. I couldn't update the progress bar before using just a single thread because the machine puked. Okay, one more time. Describe the problem that this was designed to solve. All right. Two problems. One is, with a background worker, I expect to be getting more work done because I'm adding another chef to the kitchen, okay? So unlike before where I had one chef who just flat didn't stand there and stare at the toaster, here I have two chefs. One of them is doing this background task, and the other could be doing something else. So this does speed up the process. So background worker is designed to speed up the process. Plus, it'll using the technique of events, I can update the other thread. Thread 1 spawns thread 2, and I can still talk back and forth between the two using something that's kind of sort of analogous to crew, but it's using events. Okay? Got it? Okay, could you describe this to me like in a test question? Why are we doing this? What's the use case for asynchronous, and what's the use case for background? Could you do that? If not, you might want to read this over again one more time. Okay, so there is an entire thing in Microsoft, because this is a fairly common thing, this thing called a parallel tasking, that Microsoft has spent an awful lot of energy making this incredibly simple to set up. They have this thing called LINQ is language integrated query. Okay, so one of the cool things in language integrated query, it can do lots of things. You could use it like a database, or you could use it to look up contacts, or you could look at all sorts of weird things. LINQ, language integrated query, is you could use it for finding the last value in an array, or those kinds of things. It's very powerful. Okay, so parallel LINQ library. What happens is you write your application in whatever you want, whatever compiler you want, and then it gets passed off to this Plink. I know it sounds goofy. Plink execution engine, which figures it all out. It runs the appropriate task library and then fires up a bunch of threads, does its thing. So they have made it so that if you want to parallelize, you don't have to know anything about the nitty-gritty. You don't have to ask the machine, how many cores do you have? Okay, let me give you another example. I wrote an application that you have one machine that scans the entire network, okay? Well, I could do like scan one computer and then wait, and then scan the other. By the way, it takes like 20 seconds to completely scan a computer. So fire up and wait, fire up and wait, fire up and wait. That's kind of dumb. Or I could fire up a lot of these in parallel, okay? I could fire up like 10 of them in parallel. So 10 of them are all talking simultaneously. But remember we talked about the limit? What's the practical limit? Well, doing parallel processing, the practical limit probably ought to be the number of cores you have. And there's some debate on whether or not you mean physical cores or logical cores. So at the beginning of this application, the first questions it asks is, how many cores do you have? And if it says 16, well then I'll say, well, okay, I'll probably take, maybe I won't take all 16 because that would be kind of annoying to the rest of the people. But I'll take 12 of them. And so I'll take 12 cores and fire up 12 of these guys at a time. So I have 500 machines I need to scan, but it's scanning 12 of them at a time. Okay, does that kind of make sense? So parallel makes things tremendously faster. But in my case, I had to ask the machine, how many cores do you have? And therefore I'll do that amount. The parallel link guy, you don't have to do that. You just say, hey, here's my task. And it goes, okay, we'll figure it out. So you don't have to know anything. Isn't that pretty doggone cool? It'll figure out exactly how many threads it takes to fire the thing up, the optimum number of threads, and fire them all off. It's pretty doggone cool. Anyway, again, I'm not trying to tell you how to do parallel programming or teach you about that. You just need to know a little bit about it to be able to say, what the heck is it all about? And that Microsoft has gone way, way out of their way to abstract this to make it easy for you. Okay. That kind of sort of makes sense. There's some really cool examples. There's a URL in the lecture notes that goes to a specific example if you wanted to look at it. But really, all I want you to know is just a little bit about what all this is all about, because this you might be doing in real life. You will probably be doing asynchronous in real life. You will probably be doing a single background worker or a single task like I did in the first example. Those are fairly common. But if you wanted to do something that's super complex, well then you probably need to go over and use one of these pre-built things. All right, the very first example I had was that find the smallest guy, remember that? And I manually did it in 2 tasks, okay? Okay, good. So those are some examples of parallel tasking and background working and asynchronous that you probably are going to actually use in real life. Okay, we've reached the end of this chapter, and hopefully I gave you some real world examples of how this would come into effect rather than just some of the stuff that they have in the book. Okay, see you guys again at the next chapter.